Thank you everyone for attending today's webinar, Simulation-Led Design Using SolidWorks and COMSOL Multiphysics, brought to you by Design World Magazine. We'd like to thank our presenter, Laurent Aulas from COMSOL, for being here today. I'm Evan Yaris, Senior Editor and Analyst, and I'll be your moderator today. Just a couple of housekeeping details before we get started. If you'd like to tweet about this webinar anytime during or after, you can use the hashtag #DWWebinar. We will have a Q&A session after the presentations. Go ahead and submit your questions and we'll ask them after all the presenters are finished. Laurent Aulas joined COMSOL in 2006, and he is currently leading the development of the COMSOL Multiphysics Live Link products, including the Live Link for SolidWorks. Prior to this, he worked with applications in structural mechanics and CAD integration for simulation. Laurent has an MSc in Materials Engineering from Uppsala University, Sweden, at the University of Houston. He also has a PhD in solid mechanics from the Royal Institute of Technology in Stockholm, Sweden. Laurent will be available to answer questions after his presentation. And now I'll pass the baton to Laurent so we can get started.
Well, thank you very much for the introduction, Evan. So I will be starting off talking a little bit about simulation-led design and how COMSOL Multiphysics comes in really handy in simulation and thinking about design and simulation together, how the product development can benefit from simulation. And then, of course, central in this webinar will be how do we actually interface CAD? How do we think when we want to incorporate our designs into simulations? And in that part of the talk, I will be talking a little bit also about the tools that you can use in COMSOL Multiphysics to do simplification, modification of your CAD geometry. Now, the last part of the talk will be about the Live Link interface for SolidWorks, and I will also present a demo on how you actually work together in the two software. Then at the very end we'll have time for a few questions, so feel free to type in questions already during the presentation, during the webinar. I will try to answer a few of those, and any questions that will get unanswered during the time that we have today will be answered after the webinar through our support system. Well, I'm not sure what happened here with the slides. Could we please get back to that? Let's see, go to slide. This one. Well, I actually got an introduction through Evan, and it would be actually nice to get an introduction of our attendees as well. Now, of course, that's impossible to introduce all of you to me, but one way of introduction is to do a poll question about what software you are currently using. Now, if Leslie could launch the poll question while I'm reading the various alternatives here, if we have any users for COMSOL Multiphysics and Live Link for SolidWorks, then you could select that alternative. Or if you use only COMSOL itself, or if you currently only use SolidWorks, or if you use any other software, then you could select the last alternative. It kind of gives us a background on what you have been working with, and depending on if you have completely new users, I probably show a little bit more about the interface or the parts of the COMSOL interface during the webinar. So let's see if those results are in, and actually I can see the results here. Most of our users or our attendees today are SolidWorks users. Actually almost half, about 40%, said that they are using SolidWorks only. So for you, yes, you're really interested in about learning the integration that COMSOL provides for SolidWorks. Now there are several users, about 25–26% of you answered that you actually use only COMSOL, and I think you're probably interested to know about the integration because you're thinking about using more complex CAD geometry for your simulation. Now a lot of people already indicated that they use both products, which is nice, and you might actually learn some of the news that we have in these products in our latest release. So let's move on then. To the next slide. So as I said, I would be starting to talk a little bit about the product development and how do you actually apply simulation in product development. Now, if you look at the bottom of this slide, I tried to roughly show just the various stages that the product goes through before being able to launch it. So early on, of course, you start at the very first stage when you analyze the various concepts and make some kind of feasibility study. You are very much interested in the physics at that stage and not that much interested about how the actual product will look like. So this is when you test your ideas, you make sure that the concepts of the physics hold up. And on this slide I try to illustrate this stage with this model of a loudspeaker membrane, where you kind of study the interaction between the membrane and the surrounding air. Now at this stage, of course, simulation is really handy because you are working with simple geometry. You are really after the physics and not as much the geometrical detail. You can isolate maybe just a few elements of your design to study the influence of those elements. During the next stage of your design, you go a little bit more complex. You actually study the effects of the components, the size, the performance, power consumption. So if you think about this loudspeaker design of the membrane, you can actually include the voice coil that's driving the membrane together with all the electromagnetics modeling, and then you can start expanding to the actual enclosure of the loudspeaker. So this is when actually testing of prototypes comes into play as well. And we all know that testing can be really expensive and sometimes also prohibitive, because you might have very long lead times for certain specialized components. You might run into limitations because of the time. You need to finish your design cycle within deadline, and that's just not feasible because of the number of tests you plan to do. So with simulation, you can actually run virtual experiments. You can, before even touching a physical prototype, you can run a series of tests where you get a pretty good idea of how this particular component is going to behave. Now, COMSOL is really a very good tool for actually running these tests, because during the testing phase you can add components and you can add physics. So you have a flexibility when building your simulation model that can run from a very complex all-inclusive model with all the physical interactions to studying just certain parts of it. So you can learn the various stages and add complexity as you go, both when it comes to the physics or the geometry itself. So why is testing so important then, or rather virtual experiments and simulation during this process? Well, because by the time you get to your production or process planning, at that time you discover certain errors or faults in your design, it's very expensive to correct. And the earlier you discover those problems, the better off you are. And of course, setting up models does not require them the same complexity from the beginning if you try to capture effects very early on in your planning. Now, I apologize that my slides kind of got a bit thrown off here, but I think I want to show this slide over here. Now, with COMSOL Multiphysics, you can create simulations in an all-inclusive environment where, as I pointed out before, you can add components to your model and remove components as needed. And they include the physics, the geometry operations, you have the solver settings, and all your post-processing visualization or data processing needs. You can very easily modify all these steps because they are actually recorded in the user interface. So the user interface provides all these in one single environment where you can add the components as you go. The multiphysics part of it, I guess it's something that's important because you can link just about anything to any other physics. You can take, for example, as if you think back to that loudspeaker example, you can take the electromagnetics, link that to the structure of the membrane, and then link that how the air is affected by the movement of the membrane. You can also adapt the physics. We have a lot of predefined interaction types, but you can also adapt those to suit your own needs because you can actually modify the equations that are below the predefined interactions. So based on this, we like to say that we have a really usable environment where you always have the right tool to do the job for your simulations. Now, of course, simulation is just one side of this. You can, if you are used to doing simulations, then you pretty much know the requirements for being able to deal with finite elements. You know that you need to create a mesh, and you know that what type of geometry lends itself for easier mesh generation, how you would like to modify that. And that is especially true if you already practice simulation-led design, so that from the concept stage you develop your models for simulation. But that is not always the case, because a lot of times you already have a CAD design that has been developed with manufacturing in mind. And it's important to realize that CAD for manufacturing is something completely different from simulation. So the emphasis is on the specification of the product itself, on tolerances and manufacturability of the product, rather than the emphasis with simulation that's on the virtual prototyping, capturing the concept of the physics. So there's some interface required in between. And with COMSOL, we do provide a lot of tools for being able to deal with CAD design and being able to simplify and modify. And part of this talk will be actually also about how to think when you are doing this. Because it's not only about the interface, it's also about how you actually want to go by in modifying your geometry to make it available for simulation. So let's advance it one step. And actually this time I think the slides are in order, so I can just go on and advance them manually. So what is the first step when we take a look at a CAD design? And something that comes to mind is, of course, to model everything, because the more detail I include, the better my multiphysics simulation is going to get. Well, that is not necessarily true. Unfortunately, it's actually quite the opposite. If you include all your details in the simulation, a lot of times you might not be able to solve it because you would require quite a lot of computer resources. You would have a very large mesh for your finite element simulation. But also, even if you solve it, those details might just actually hide the important features of your analysis. So rather than looking at real effects, you would be looking at effects that you don't really have any control over, and you would not realize what you're dealing with. So it's quite important to modify and simplify when dealing with simulation. So the first question I guess you want to ask is, what is the scope of your model? What kind of detail is necessary to be able to get the answers that you want? And when you get to the physical detail of doing it, then what you want to look at is how to remove components, how to maybe merge them if they have similar properties, how to apply assumptions about the symmetry in the parts. So I had this picture of a piston and conrod assembly, and if we think about it, we would like to probably do some kind of a structural and heat transfer analysis on it. Then at the first approximation, we would probably remove a lot of parts that are not really necessary to give us some answers, and might remove the retainer ring shown in the upper right corner of the slide, or some of the O-rings that sit around the piston. We might just want to fill out the space with the material properties, but incorporate it as a much simpler domain in the analysis itself. So, for example, in COMSOL you have tools to merge objects together. You can, by merging those together, you have a lot simpler interface with a lot lesser spaces that you need to resolve with the meshing. Then you would be able to have the same material properties throughout the actual component itself. Now you might also want to identify some symmetry planes, and know that sometimes an assumption is good enough. So even though a quarter of this is clearly not giving a symmetrical part, it might be enough for a first assumption, just to capture the most important details of your analysis when setting up your model. Then of course, you might also look in components in general. Can you remove some parts of some details of the components? This is always a difficult part of your simulation, because it's often hard to say what is it that's not necessary or is necessary. One good rule is, of course, to start with as simple model as possible. It's a lot easier to set up the physics and solve the model, and it's important to realize that you can always add details as you go along. So once you've solved a model, you can add more details to it, to the geometry, and then solve it again. And it makes a lot more sense. Now, usually details that are very small, you can always remove, because they would not be resolved to enough accuracy by the mesher anyway, unless you really have a very large mesh. And by small in this sense, I mean things that are about 10,000 times smaller than what you're studying, what you're looking at. Now, larger details can also be removed, and of course you want to look for rounds or holes or other features that might not be central for the analysis that you are dealing with. Of course, it's always important to keep the physics in mind when you're doing these things. So it's good to know what you're doing. Just a few examples on smaller details here, and sliver faces are usually causing a lot of problem in CAD design, because a lot of CAD software, especially when you're using surface-based modeling, they don't really care about the partitioning of the solids or the surfaces of the solids. And this introduces very, very narrow faces with a large aspect ratio. Now, if you have to resolve this in your mesh, you would have a large mesh, and it would become very costly to deal with those. Now, you have several ways of removing these in COMSOL, and a lot of times you can actually also do it in SolidWorks or other CAD software, but that's not always true. Another example here showing how you would remove certain smaller rounds from the geometry. And finally, just to show an example, you can actually freely select larger details as well from taking it out. So in this case, you would say that I've taken out the bolt, but I still want some material there for my heat transfer analysis or the structure analysis, but I kind of assume that it's just part of the conrod, and you just select those faces and remove them and fill it up with material in just one operation. The same way you would be able to actually select the groove where this retainer ring was sitting for the pin. Of course, when you remove it, you fill it up with material, and it's the same thing as the ring would be there, although you have a lot less details in your geometry now. So now the question is, of course, how would you go by doing this? Now in COMSOL you have a range of tools for modifying the geometry, and they're typically very well suited for removing small details. These operations that you're doing in COMSOL, they're actually saved in a sequence of geometry operations, so you can always go back and activate those again, the ones that you find are important for your analysis. And of course, if you're familiar with the COMSOL interface, the good thing is that you don't really need to know about how you would go by in the CAD software to do it. But if you actually think that you would like to work in the CAD software to do these kind of modifications, so you would like to work in SolidWorks, that's also possible. And I just need to find that slide because it got it's up here actually. All right. So when you're working in SolidWorks, you can also simplify geometry, and it's quite easy there because you have the history of your design available. Now, easy is a word with modification, because a lot of time it's actually the opposite, since it might lead to conflicts. Now, if a CAD design has been made in a way not following certain design rules on how to apply the features, then if you make a change, it would actually cause a lot of errors when you're rebuilding your design. So that is something you have to weigh depending on what change you want to make. If you want to make it in SolidWorks, on COMSOL, depending on the complexity of your part, how well designed it is, and whether you actually understand the dependencies inside your CAD design in SolidWorks. And of course, this is always easier if you are really good, if you have really good knowledge of the SolidWorks user interface and the SolidWorks tools. So I think that kind of takes us to our second poll question, just to see here the workflow that you have in mind, and what is it that you prefer to do in your work. So Leslie would see if you would show the second poll questions that we have today. I think the choices are quite easy here. So based on what you heard, you might have a preferred workflow here if you want to work in SolidWorks or COMSOL Multiphysics, or some of you might even have other tools you would like to use. And as we're getting in some answers here, I can see that about 50% of those of you who answered the question actually say that you would like to prefer to work in COMSOL Multiphysics. But we are still getting in answers, and right now it's actually quite closer. The alternatives, SolidWorks and COMSOL Multiphysics, are quite close. And that kind of, I think, reflects realities. It's almost 50% on both of those two alternatives, about 45% each, and 10% who would prefer to use other tools. I kind of agree with those who say both SolidWorks, or if you say SolidWorks, I agree with you, and if you say COMSOL Multiphysics, I also agree with you. And I think it kind of depends on how well you know those tools. So those of you who really learned the editing tools or geometry modification tools in COMSOL, you probably prefer that. And those of you who are really efficient in using SolidWorks, you would prefer that. Of course, when you are also have a knowledge of a third tool that can be beneficial, I would say that if you are using both COMSOL and Multiphysics, you should probably not start learning another tool, because I would say between COMSOL and SolidWorks you probably cover most of it that you want to know. But yes, if you already have a third tool that you're using, then of course it's pretty good to go ahead and use it. Now I'm going to do another jump here, and hopefully that will be the last one for today. But I think I arrived now to the third part of the talk, which will be presenting the LiveLink for SolidWorks interface, which kind of brings COMSOL and SolidWorks together. So let's move down one more slide. Okay, finally. Now, LiveLink for SolidWorks is really the interface between CAD and simulation, in the sense that enables you to integrate your COMSOL model into the simulation, into the design environment of SolidWorks. And it does that in several ways. First one, of course, is the bidirectional interface that allows you to use the two softwares side by side. And in doing that, you are able to reuse your COMSOL model for multiple CAD design configurations. Usually, when working with this prototyping, this virtual prototyping, is all about studying variations of your design and testing the variations. So, but the more time you can save in setting up the model and running all these virtual experiments, of course, the better off you are. So the LiveLink for SolidWorks provides the link between the two programs by bringing over the geometry into your COMSOL model, and it also gives you the possibility to modify it from within the model. So by that you have the capability of leveraging over all the built-in functionality of COMSOL for being able to run parametric sweeps in order to find your optimum design. So the alternative to this would be, of course, that you would save or your variations to CAD files, and you would import them using file import, which is also possible, but then you have a lot of bookkeeping to do in administering all the changes and making sure that you have the right file together with the right model, etc. So it's a lot easier, I think, to use the LiveLink interface and just run a parametric sweep, which would automatically create those variations for you. Now, it's important to realize that all these changes that I've been talking about for the modification of the geometry, all these tools that you can apply to the feature and geometry operations to modify, they can be done also in conjunction with transferring the geometry with the live link interface. So you still have the possibility to bring something over with the interface and then modify it inside COMSOL. That should also work. And again, the live link interface integrates into the same environment that contains the whole of COMSOL Multiphysics. So you can leverage of all the other possibilities of cluster and server connections and computing. You can integrate it with the live link from MATLAB for scripting capabilities as well. Now, how does this work? Well, you have, as I mentioned it before, you transfer geometry to COMSOL, to your COMSOL model from SolidWorks. And from COMSOL, you can actually transfer parameter value pairs to initiate the modification of your design geometry. And then, of course, the very nice part of this is that you can all run this automatically. So you can set up a parametric sweep where you say that I want to see what happens with this model if I modify these parameters, and COMSOL solve this problem by sequentially just updating the geometry and solving the physics, and this is all together with automatic mesh and automatic solving and generating of results as well. Now, you would ask probably a question about how does this work together with assemblies in SolidWorks, and of course we all know that products mostly contain several objects, so the interface does transfer assemblies. It transfers several solids also for part file that contains multiple solids, and not only that, but you can modify parameters on all levels of your assembly. You can have dimensions in a certain part, somewhere in a sub-assembly, or also on the top level file when you are working with this connection. Now, it's quite new actually. In the latest release of COMSOL, we also provide an interactive way of selecting parameters to be connected or linked to your COMSOL model inside the SolidWorks user interface. I will demonstrate that in just a second. So the live link for SolidWorks also provides an integrated environment, and I'm not sure if some of you have already used this. If you're a COMSOL user, we introduced this maybe a couple of years ago. It's getting more matured now, and it makes COMSOL Multiphysics available inside of SolidWorks. So if you are a SolidWorks user that prefer to use the SolidWorks environment, you don't have to run the two software separately side by side, but you can actually use it inside the environment that you're used to working with. Now, there are some benefits, of course, associated with working inside SolidWorks, and that's because we can automatically detect changes on the geometry, and it's as soon as a change is detected and you switch to your COMSOL model inside SolidWorks, the geometry would be automatically updated. That also means that if you add more dimensions from SolidWorks to be linked to the model, those are also automatically transferred. This process is a little bit different when you work side by side. Then you would have to have another step of actually clicking to update things. You have another advantage is that you actually can save your SolidWorks design together with the COMSOL model, actually inside the COMSOL model, to create a package that you can easily share with your colleagues working on the same simulation. So I think this takes us to a short demo of the interface between SolidWorks and COMSOL. So I would like to get the presenter status, I guess. Leslie, if it's possible. Okay, just takes a few seconds to change the presenter. And if it has
one of the questions that has come in, what is the file format that should be exported from SolidWorks to COMSOL?
Can we take the questions at the very end? I will answer that question. I've made a note of it, and I just answer that in about 10 minutes when we get to the Q&A, if that's okay.
Oh, all right. Sorry about that.
That's okay. But just before that, I would like to show the interface between SolidWorks and COMSOL. And in this case, I will show the embedded one-window interface, as we prefer to call it, when you actually run COMSOL Multiphysics inside of SolidWorks. And I think you should be able to see my screen now. I have SolidWorks open, and I will show you how to start setting up a simulation on this part. Now, this it's a small design consisting of a few solid bodies. I think there's 13 solid bodies in this part, and it's a power transistor. In this model, it's a multiphysics model. It will simulate the heat transfer through this device, and there's heat generated from a heat source, the actual transistor chip that sits here, and there's also heat generated as the current is flowing through in the circuit board. So when you have COMSOL Multiphysics installed on the computer and SolidWorks, COMSOL will add a add-in into SolidWorks, and you will see a COMSOL Multiphysics toolbar. Now I will of course want to set up a parametric sweep on this model, and COMSOL allows you to select parameters that you will link to the COMSOL model from a simple GUI, where you can basically click in your feature tree in SolidWorks. So for example, I can click on a feature, and it will appear. All available dimensions for that feature will appear in a table, and from here I can select the one that I want to add to my COMSOL model. And this is actually a very simple process. So for example, if I would like to add this dimension of the backs of the transistor, I just click the add button, and it will end up in this table of parameters that will show up in my COMSOL model. I could also actually want to see what happens if I change the size of the transistor chip, assuming that there will be more heat generated. In that case, I add that parameter as well. And when I'm done, I just click OK. Now if I want to start my COMSOL model, I just click the new COMSOL a new model button in COMSOL, and it takes a few seconds to do this. COMSOL actually processes the geometry and resolves the domains resulting from all these parts, all these solids that make up your SolidWorks model. And then as soon as that is done, you will get to the model wizard, where you can select the physics. Now it will be the Joule heating in this case. And then of course you want to select the study type you want to do. I'm not going to go into details about the physics at this time, so I'm just going to step through this quite quick. Now the model wizard kind of sets up the initial model for you based on the physics and study type you would like to do. And once that is done, you will see that the COMSOL model tree appears in the left side, where you usually have your SolidWorks feature tree, and then to the right you have a window showing the settings. So if I click on a node, I will see the settings on the right side popping up for that particular node of my model. If I look under the geometry node in the model tree, I can also see that there's a live link for SolidWorks node. Now, this actually contains, you could look at this as the node that symbolizes the connection, the link between my COMSOL model and the SolidWorks file. And this contains also the dimension that I've selected from the SolidWorks design to be transferred to COMSOL. So basically, it contains these two dimensions, and they are associated to a COMSOL parameter that was automatically created when I started this model. And it's important to have this because COMSOL, of course, is working in its own parameter space. So for the COMSOL solver to be able to drive a parameter to change its value, we need to have a parameter that is associated to a SolidWorks dimension. Now you could name this anything really, as long as it's set up inside COMSOL, but the live link interface creates a name that is based on the SolidWorks name of the dimension. And then this parameter will actually appear under the global definitions of your COMSOL model. And this is where the COMSOL solver can drive the parametric sweep by changing the value of this. And I could actually manually change the value here from 19 millimeters to say 22 millimeters. Let's see what happens. And now note that when I go back here to the live link node, I can see that there's a little sign here saying that this needs to be updated. And when I update this, actually what's happening is that the SolidWorks model is changed. And now we can see that the design has actually changed a little bit. This back plate has become a lot taller here. And if I go back to SolidWorks and click on go back to the SolidWorks file and click on the operation there, we can see that the value is changed to 22. And this is really the way the COMSOL solver drives it as well, although automatically. Now, what I've done here is that I've started up a model, but how would you continue? Well, it's quite simple, because now I would just go on and apply some materials for my physics. And I'm just going to do this step. So I would open up the material browser that also opens up here to the right, and I want my, a lot of this will contain copper, the pathways where the current is led, for example, and I can search for copper in our material library, and I want to add it to the model. Now, by default, all of the domains, all of the parts making up this will be applied to this first material that to add to the model. Any subsequent ones will override this setting where you want to apply some different material settings. So for example, if I look for the material for the circuit board, and I want to add that as well. Now I'm just going to click on the circuit board there to apply the material setting for that. And if I switch back real quick to the copper, then we see that domain number 1 in the selection list for the copper material is overwritten by the setting where I applied the material for the circuit board. Now you probably noticed that selections if you are both a user of COMSOL and SolidWorks, you know that the selections work a little bit differently. In SolidWorks, you select by just clicking once, and then if you click again on something selected, it would get deselected. And that's another feature of the integrated one-window interface, that you would use the selection model of SolidWorks on just clicking once on the various parts to select them. All right, and just to finish this demo off, I will actually show what happens when you save things together, so to say. And this model, of course, I've solved this model and I saved it in a way that's linked to the SolidWorks file. And since the SolidWorks file is already open here, I just switch over to it now. What I can do is I can check if there's been any models that are linked to this. So I have an open linked button here, and there are about five of these files. So I just select the first one there. This model has been saved with a complete solution. And when I open this, of course, I would just show you real quickly a little bit about how post-processing works, and that will be the last part of this demo. So as you can see here, we can see the temperature field in the model, so that which means that I've already solved this physics that was set up inside the model. And here I can quite easily just click somewhere in the graphics window to get a temperature reading in a table, in the COMSOL results table. But I can also use tools to get a profile of the temperature through this part. So I can just click on the cut line direction, where I can define a cut line through my part like this. And then I can scroll down here and look at the plot on how the temperature looked like along that line, which is shown in a separate figure. Now, as a very last step, I would like to show them how you would go by to actually set up a parametric sweep. And that is quite simple. As I mentioned before, all these steps of dealing with the physics and the solver and the post-processing are inside the same user interface. So all you have to do is find a node called Study in your COMSOL model, and then when you right-click on that, now this node includes all the steps needed to set up a solution, to set up the solver. And the solver configuration is pretty much automatic. You don't really need to concern with it unless you're doing more complex things. But for the parametric sweep, you would just select parametric sweep, which brings up the settings for this feature. And notice also that it has been added to the left here under the study node. So now we can do a parametric sweep in the model. And in this case, you need to select which parameters you would like to control. Now remember that there were some dimensions that I've linked to COMSOL, and there's the first one was called D1 at sketch 2. So this was a dimension at sketch 2, and there was a COMSOL parameter that was set up so that it's linked to the dimension. And you've seen that I clicked the plus sign here to add the COMSOL variables. Now I could have a sweep over multiple. As you see, as a table here, I can define multiple parameters to sweep over. But I will just do one simple sweep. And I have a button for defining a range for my parameter sweep. So I could sweep from, for example, 2 millimeters in a step of using a step of 1 millimeter, and I would stop at 5. Okay, and that's really what will happen when I click the Solve button. Then COMSOL would automatically solve this model for this range of dimensions. All right, well, I'm I can actually just right-click here and compute. That will take a few seconds. But I guess we are also getting close to the end of this session, so I will just minimize this while it's stalling and give back the control to Leslie for showing those finishing slides. So let's see, maybe I should just move down if I can get the controls. Now you've seen some features of COMSOL, of course, and it's hard to cover everything in just one short webinar. Oh man, I don't know why I changed it back, but what I wanted to remind you is that COMSOL, we at COMSOL offer quite a lot of workshops that are free, and if you visit the COMSOL website, you will be able to take a look at where they are offered and also sign up for any workshops of interest. Then, of course, as every year, the biggest event is really on the next slide, and that is the COMSOL annual conference that is held at several locations throughout the world. So in North America, it's usually in Boston. In Europe, we alternate between various countries. This year it will be held in Milan, and we have several locations in Asia, most notably in Bangalore in November. Now the COMSOL conference is a great opportunity not only to present the work that you're doing, but to actually take a look and interact with other users of COMSOL. It's actually I really enjoy myself being there and talking to COMSOL users. So if you can, make sure to this year, make sure to find me and ask any questions there as well. So with that, we arrive to the Q&A session, and any questions that you have, we will answer, even if we don't have time today. We will make sure that all questions will be answered through email. And
thank you, Laurent. Yeah, we have a number of questions that are interesting from people who have been watching, and maybe I could pass some of them to you and you could answer them. Would that be okay?
Yes. I could actually just start right away with the question we got there somewhere in the middle of what file format to use when exporting files from SolidWorks to COMSOL. Now, both actually COMSOL and SolidWorks at this point are based on the Parasolid file format, and COMSOL, the LiveLink from COMSOL product or the CAD import module, they add that functionality. So Parasolid is a good format to use. Of course, with COMSOL, either a CAD import module or the LiveLink for SolidWorks, you can also use the SolidWorks file format itself as well. I would say both of them are just equally good to use for file transfer between the two software.
The next question is for large models, for example, a whole airplane that's built in SolidWorks. Do you recommend exporting the whole model or into components?
And now that's a very tough question, because large models, it depends, of course, what you want to do. Now, if you really want to study the whole airplane that you have, then you would export it as one one piece, as one assembly, and then import it to COMSOL. Now I would assume with a large model that you would probably have to consider a lot of simplification and modification as part of your modeling effort. So again, as I pointed out, some of them would probably be good to do in SolidWorks, other would probably be good to do in COMSOL.
I imagine if you're building whole airplanes, you've probably got entire departments that are running COMSOL.
Well, hopefully, yes.
Another question is, how many live links are there? Are there live links to other CAD products beyond SolidWorks?
Yes, we do have other live links, and let me just actually advance this down to our I had a few slides here just to support our Q&A session, and you can see our product suite here. Now to the right we have these interface type products where with all the live links, and if I just count here quickly, we have SolidWorks, ProEngineer, Inventor, SpaceClaim, Creo Parametric, and AutoCAD. So we have 3 live links for CAD products. Now essentially ProEngineer and Creo Parametric are of course the same, but it's a different technology, so they still count as 2, I think.
There were a couple of questions regarding licensing of software, and I'm assuming that people go to SolidWorks to buy the SolidWorks license and go to you to buy the COMSOL license. Is that right? Yes,
that is correct. So we are distributing only our own products. And then of course, depending on where you are located, you might have to go to a reseller or either directly to us to license either COMSOL Multiphysics or the live links.
A related question about SolidWorks is, do you need to have a SolidWorks simulation package to use COMSOL Live Link?
No, that is not necessary. So all you need really is the base SolidWorks package.
And is the SolidWorks environment a full feature environment for COMSOL? Can you use all of the COMSOL modules within SolidWorks?
Yes, pretty much. There are very, very few things that are not exactly the same as you would use, as if you would use them side by side. But yes, you can use all of the physics. Of course, with the limitation that it's 3D. Because SolidWorks is a 3D modeling environment, and the live link is only for transferring 3D geometry. So that's, but I guess that's something that we assume that we are dealing with here. So
another question, and I think this one's an interesting one, is about how hard is it to model cables in COMSOL and SolidWorks, and he's talking about crane cables, which would be high tension steel cables. Not electrical cables, I'm assuming. He says that they're having trouble with their current software trying to model those.
Now, this is a tough question because it could be hard for various reasons. And of course, I'm not sure if that's something that I could answer here just based on the detail of what the user provided here. Now, of course, there are some geometrical difficulties associated with modeling cables because they have very high aspect ratio. So depending on what you want to do, you might not actually want to model the cable as a 3D object, but rather as a line, and that's possible to do. But then there might be probably some aspects of the physics that are not captured by such a model, and in that case you would have to turn into a full 3D model. Now in COMSOL you have flexibility in the meshing because you can also create swept meshes, so that's a lot easier when you are dealing with objects of high aspect ratio. So I would say that for the user to submit questions, talk to one of our customer representatives, or use our support email, support@comsol.com, to ask this question. It can be answered in more detail.
This is why you have PhDs. There's a couple of questions that were sent in via email. One is, what's the difference between the live link for SolidWorks and the CAD import module?
Well, the live link contains this interface where you actually don't have to deal with the file import. So the geometry is transferred directly to COMSOL automatically. And it also provides this embedded one-window interface where you can actually model with COMSOL inside of SolidWorks. So the CAD import module provides you only the file-based import, where you would have to save a file from SolidWorks and then import it into COMSOL. Both of these would provide you with the tools that you would need inside COMSOL to modify and simplify geometry.
Great.
So maybe we take one more question, and that will be the last one, or?
Yeah, we're just about, well, we really are out of time, but the next one is, how do you save a COMSOL file when using the one-window interface for LiveLink for SolidWorks?
Well, actually, that's something that I'm not sure if I showed, but it's really easy. We have tied into the SolidWorks save mechanism, so you would just use save as in SolidWorks as you would just save a SolidWorks file, and once COMSOL is installed, of course, there will be an alternative to save a COMSOL model as a COMSOL file, basically. And it's really, really neat because these files that you save from SolidWorks, they can also be opened up in the standalone COMSOL. So if you have a COMSOL Multiphysics running separately, you can then take a COMSOL model that has been created in SolidWorks and open it. Of course, it would, if you have the license, you still need the license for the LiveLink for SolidWorks, or at least the CAD import module to be able to view such a model.
Great. Well, the rest of the questions that we have, we're going to answer them via email. The folks from COMSOL will be contacting you via email, so don't despair. And if you have any other questions that you'd like to ask, you can contact COMSOL directly. My email, well, I'm pretty easy to find. I'm eyaris@wtwhmedia.com, or you can just look on Google. Just Google Evan and CAD, and you'll find me. I want to thank everyone for attending the webinar. A copy of the presentation is going to be emailed to everyone later today, and it will also be available on our website at designworldonline.com. Thank you very much.